Today we are going to take a look at how we graph exponential functions. Okay, now there's some pros and cons to this. Exponential functions. When we are graphing exponential functions, we don't actually have to learn sort of all the crazy things like we did with quadratics with, A, H, and K, and finding a vertex, and standard form versus vertex form, and all those sort of pieces. Okay, we don't have that piece, but we do have sort of an interesting thing that happens with graphing exponentials. So when we are graphing exponentials, they're in the form y equals a, b to the x, plus c. So what makes it an exponential is all of a sudden that variable is no longer the base, but the variable is now the exponent. Okay, and exponential functions all have a variable as the exponent. Okay, so when we are looking at this format, excuse me, just like before, that A, B, and C tell us some important information. Okay, so the A is still going to tell us if it opens up or if it opens down, but we're gonna have a different shape this time. Okay, so, right, new type of function, new type of shape. So our exponentials are now going up or down. Now you'll notice this side over here doesn't sort of curve back down. It actually goes right up against a line that we call an asymptote. We're going to talk more about that in a minute, right? That's a weird word. Okay, the B value when we are graphing an exponential always has to be positive. Okay, if it's negative, we actually were having a long dorky math conversation about this earlier today. It just ends up as a big mess. It's not even an exponential function. So B has to be positive. Okay, and this C value over here is what determines our asymptote. And it's spelled really funny. Okay, but our asymptote is sort of this, it's not imaginary, it's not made up, but it's not part of the graph. Okay, this is actually going to be a line that we can't cross. Okay, and in the math world, an asymptote is a line that you get closer and closer and closer and closer to, but you never actually get on it. So very similar to when we did something like, x is greater than 2, right? You can get as close to 2 as you want, but you can't actually stand on it. It's kind of a similar idea, except it's with this line that we're approaching. Now, those might all seem like big terms, but the reality is we don't really have any other information for graphing these exponentials at this point, other than to just make a table and plug in some input and output values. So let's say that we want to graph y equals 2 to the x. Okay, we're gonna fall back on, right, this works for any function that we wanna graph. We can always make a table and we can always plug in some input and output values. Now, for this particular problem, I'm going to pick -1, 0, 1, and 2. Now, typically these are pretty good values to pick, but this isn't even like a quadratic where we have to do like the vertex and find something special. Okay, we just need to make sure we're getting, man guys, I'm sorry, I keep yawning. Clearly working too late. We just need to find some good points that give us what the graph looks like. So, just like anything else, we're plugging these in. So if I'm plugging in this -1 for x, that means I have 2 to the -1, which means we now have to remember some of our properties of exponents from way back at the beginning of the trimester. I'm sure you're all thrilled to hear that, right? Negative exponents actually tell us that we're moving it to the other side of a fraction. So if we had something like x to the -2, it became 1 over x squared. So this really becomes 1 over 2 to the first, or 1 over 2, which is 1/2. Now, you can use a calculator to help you if you need to. Okay, you can do 2 and then the up caret button, which is right here. It will give you 0.5, but we should definitely remember this about negative exponents. Okay, then we'll plug in 0, so 2 to the 0 power Remember from our properties and exponents, anything to the 0 power is, hopefully you're all saying 1. 2 to the first power will give us 2, and 2 squared will give us 4. Okay, so I think when we go to graph this, sometimes it's helpful to have either like 2 different colors or maybe a pencil and a pen or something of that nature. Because when we go to graph, right, I told you that this C value is our asymptote. It's the line that we can't cross. It's not part of the graph, okay, but it's sort of like this line we have to consider that's really important when we're graphing. So if we look at this problem, y equals 2 to the x plus, well, 0, right? So there's a plus 0 here. Okay, the asymptote is always a horizontal line. So we want a horizontal line at 0. So I'm going to put in this line right here and make it dashed. Because it's not part of the graph. It's just something we have to consider. Okay, and then I'm going to start plotting the points that I got from my table. So I'm going to plot the point -1, 1/2, -1, 1/2, 0, 1, 1, 2, 2, 4. Okay, so we're starting to see this sort of, I don't have a word for it, I kind of just call it a swoop. We're kind of starting to see this motion, and here's what this asymptote means. It means that this graph is going to come down in this shape, but it cannot cross that dashed line. It's forever getting closer and closer and closer and closer to it, but we cannot actually cross it. Okay, so that dashed line is telling us that we cannot cross it. If you start crossing it, then you did something wrong. Okay, so really that's kind of all there is to graphing these. So let's look at another one. Let's say we wanted to graph y equals 2 to the x plus 4. So again, just gonna make a table. I'm gonna plug in some values. I'm gonna do -1, 0, 1, and 2. I'm just gonna start plugging them in. 2 to the -1 plus 4. So this would really be 1/2 plus 4, which will give me 4.5 or 4.5. To the 0 plus 4, which will be 1 plus 4, right? Because anything to the 0 power, so that might give me 5. And again, you could use the calculator if you want to use a calculator. 2 to the 4, or 2 to the first plus 4 is going to be 6. And 2 squared plus 4, well, this will be 4 plus 4, so that will give us 8. Okay, so now when I go over to put this on my graph, okay, I'm again going to look at my C value. My C value is 4, so at 4, there is an asymptote. There is a horizontal line that I cannot cross. So let's start plotting these values on here. So I have a point at -1, 4.5, 0, 5, 1, 6, 2, 8. Okay, and so I'm just gonna make in my sort of swoop. And there is my graph. Now, both of these, I kind of didn't say a whole lot about it, but both of these have an A value that is positive, right? What number is sitting here in front of this 2? Well, that's a +1. This is a +1. But A doesn't have to be positive, so I'm gonna kind of squish this in the bottom here, but I think we'll be able to fit. What if I want to graph y equals -3 to the x minus 5? Now, normally we would just read this as -3 to the x minus 5, but this doesn't have parentheses around the -3. So if you remember, that's very different. This really says 3 to the x times a -1. So our A value here is really -1. Now, 3 starts to get a little bit weirder because we have 1/3. So I'm still going to do a -1, a 0, a 1, and a 2. And just like anything, right, if we plug those in and those values don't work, we might have to go larger or smaller. So when I plug in -1, right, I'm going to do my -3. Don't put parentheses. Your calculator knows if there's if there weren't parentheses to start with, your calculator will take care of it. Up caret, and then I want this to be to the -1 minus 5. Now, I get 5.3 repeating. Because we're graphing, I think it's okay if you put on here -5.3. It's really -5 1/3 is the exact number, but for most of you, you're gonna prefer that decimal when you're approximating. So I'll kind of let you do that this time. Okay, then if you want to, again, you could use your calculator and just change it, or you could do the math. Okay, again, if you want to just go up and change, we'll get a -8. Okay, so here we get a -14. We're gonna go ahead and go, okay, that's fine, I start graphing, but -14 won't fit on my graph. And this is the problems with exponentials. They get really big really fast. They really start to change in value. So, I mean, going to 3 isn't gonna be any better, so we might just have to go all the way down to -2. Now again, the number's gonna be weird because negative exponents cause that fraction to happen. So now we have -5.1, okay? So our asymptote on this one is at -5. So I'm gonna make my horizontal line at -5. Okay, and let's start plotting. So we have a point at -1, -5.3, 0, -6, 1, -8, and then -2, -5.1, right? And you can kind of see those are getting closer and closer. Now, this one had a -a value, so it probably makes sense to us that this one opens down.